So I solved this question and this video is coming out late. I have little task to do and let's continue. We have a question, permutation of a string. We have given a string which may contain duplicate character. Your task is to generate and return an array of all the unique permutations. You can return your answer in any order. So we have this, and different permutation can be this, and this. So we need to return array of strings which represent different permutations. We only give a single string. And in the next test case, it is pretty big, so it is difficult to visualize. And in this, we have three different permutation, but we only need to consider a unique. So there is only one unique permutation, and the answer is containing a single permutation. So I will take this example and illustrate how we can approach this question. Now let's move to the whiteboard. We have this string, so we can break down, and first of all we will consider the strings starting with a character only. So we have this path starting with a character. I have fixed my a, then we have b, and we have c. In this path we fix our b in the first location and move between a and c. In this we fix our c and shift a and b, isn't it? No, I think we will first consider b and a. It will work, but a and b will also work, but I need to focus on this thing. So we will consider b and a. You can consider a and b starting with a and b. It will also work. Then let's move on the next part. First focus on this only. I will draw the tree for other paths also, but first let's focus on this. Then from this particular string we fix our a already. Then it's time to fix b for this path. Then we have c. Then we have fixed our a, we have fixed our b. It's time to fix our last character, right? And we have reached the ending. How we will detect whether we have reached our ending? So we are starting from this index. We have fixed this index. Now we jump into the next index. This will be my starting. I have fixed my starting. Now it will jump to the next index. This is my starting. I have fixed my starting, and if I jump onto the next index, we have reached all the index. We have reached 3 index. Now my s will reaches to n. I know this is my end point. We don't have any more strings to fix, so this is my end. So I will consider this. On the next example, on the next case, we have fixed this and there is no more characters, so we cannot find any more permutation. But from here we can find one more permutation. On this stage we have fixed our b. On this path we will fix our c first. So we have fixed our a, we have fixed our c, then we fix our b. On the next path we will fix our a, c, and b, the last character. This is my end point. And we have solved for all the paths starting from a. Now if we fix our b first, so we have two different paths. Actually first focus on the first path. We will fix our a and c remain as it is. In the next stage we fix our a, we fix our c also. This is my end point. I will consider this. There is no other path from this. There is only single character that we can fix, and from this index we can fix our c first. We have already fixed our b. Now it's time to fix our c. So we have fixed our c, and on the next path, on the next stage, we will fix our a also. So we have fixed this, and that's it. All the paths we have considered starting from b. Starting from c, what path do we have? We will fix, first of all, C is already fixed. We will fix our next character, which is B. We will fix our next character, which is B. We will fix our A character, and we have no characters left. From this path, we have fixed our A, B, and then we will fix our last character. So that's all. We have found all the paths. This is all the permutation that we have. All the permutation that we have. Now let's try to find what. Let's try to find out what should we need to do to find the permutation. So we have starting index as this. So first we will fix the starting index and go to the next index. Let me change the color. So we will start from this, fix this, jump to next. Then we will fix this, jump to next. We will fix this, jump to next. That's all. This is my end point. I will consider this. Then we will go back. No more string left. No more starting index. We will go back. From this, we need to find one more path. How we will find one more path? So we have just swapped the values, isn't it? Yes, we have just swapped the values. So we will swap the values. So first it will swap with itself. We got this. Then it will swap with the next character. We got the starting index is this, and we will swap this and this. So we got this value. Now this is my starting point. I have fixed this. This is my starting point. Starting point is nothing. So we have traversed for this path, and we know from the starting we will fix this, swap the index, swap the character, and jump to the next character. Swap the character, jump to the next character. Same applies on every stage. Same thing apply on every stage. First we have fixed this. Then this is my starting index. My next character is this. This is my first character that we have just swapped. This is my next character that we need to swap. So we will swap this and this. What we got? We got this. Yeah, it is correct. On this stage, this will be my starting. This will be my starting index. First, from the starting index to itself, starting from itself, we will fix this. We will swap the character. After swapping the character, we got same character. Okay. For this, we have this starting index. This is my starting index. This is just for traversal. On every traversal, we need to swap the character with the starting index. So this is the single character, and our swapped character and the starting character is same. So we got the same character. We have fixed the character and jump to the next index. We will backtrack. We will backtrack. We will backtrack. Then we have this stage. This is my starting point. I have swapped with this character. I will now swap to the next character. So I will swap this and this. So what we got? B, C, A. Yes. Yes. For this is my starting point. This is my starting point. I will swap the character to itself. We got this character. We got this string. Starting index will jump to the next character. And that's all. We don't have any further path. We will backtrack. We will backtrack. We will backtrack. This is my starting character. This is the most important point. So pay attention to this point. This is my starting point. This is my starting point. Starting from this particular index, I have swapped the value. So we got this path. I have swapped the value with this. We got this path. I will swap the value with this. I will swap value with this. So we need to write a for loop for we need to write a for loop for swapping the values. So we got starting. So I will write integer it will do the work from the starting index till the nth index, and we need to write I plus plus, swap it, ith and jth character in my string s. So I will swap the character. So we got this path, and we need to just write a simple recursive function. As I have swapped this character and this character, my starting index will jump to the next character. So I am now at this particular index because we have already fixed one character. So we have recursive function, and I will pass my starting plus 1 and string as it is. Starting plus 1 plus string as it is. So we will again apply the same principle here. This is my starting point. The underline is my for loop. I will swap the character. So this is the same character. So we got the same string. This is the same string. Starting index will jump. This is my starting. This is my swapped character. So we will swap it. We will jump to the next. And that's it. This is my ending. Now we will backtrack. And move to this path. So on this, first my starting is this. This is my for loop. The underline is my for loop. I will swap it with this. My for loop will increment. I will swap it with this. So I made a mistake here. I just realized. So we have A and B. A and B. So this is the correct permutation. And yes. So swap it with this. Already did. Swap it with the next character. We did it here. So we my starting will increment. This is my starting. This is my for loop. Just swap the value. Already swapped, and we got same string. My starting index will jump. What's the base case? If your starting reaches your n, just consider this string and return back. Return from this condition. This is my starting point. And we have missed just one thing, and uh, everything else will work. We have just missed one thing. So let's suppose we go on this path. This is my starting. This is my for loop. I will swap it. Okay. This is my for loop. I will swap it. We got this path. This is my starting. This is my for loop. I will swap it. This is my starting. So starting index will do the work. Then we will backtrack. But we have already swapped it. This is my starting. This is my ending. I have already swapped ACB. That's why we got this. So to backtrack, to get back the original string, we need to again swap the same character on the same position. This is my starting. This is my for loop. I have swapped. So that's why we got this path. Again, from this path, to get back this string, to get back this particular original string, we need to again swap my starting and my for loop index. So from this, we will get back our original string. We need to just write our backtracking condition. Recursion, this step that we just performed, which is swapping with the starting index. So again, perform the same operation to get back the original string. This is called backtracking. And that's it. This much code is enough to find the permutation. Let's code this. And we need to find the unique strings. So let's suppose suppose we got k 3 times k. My permutation function will consider k 3 times, and um, it will try to find the permutation. So it will give me permutation all the of all the different ways. So we got k 3 times, actually 6 times k. So if we got k k k, so we got 6 different endings, and on these 6 different endings we got same kk's. So that's why I will consider set to find the unique values. As set, just a simple solve function. Solve function, this is my starting, this is my jth index. Swap the character, then jump to the next character. That character will be my new starting point. Return back, and this is the swap function. I have converted my string to array, to character array. So now it is pretty easy to swap the character. On the string itself, it is pretty difficult to swap the character on the ith and jth position. So that's why I have converted into a character array. Now one thing is missing, my base case. My base case will be if my starting index reaches n, consider this, consider this and return back. So uh, in Java language we need to write new string. So we are creating new string. If you consider only a, or if you are passing your s here, and you will get your s here, and you will just consider s, it will just add the same string, because strings on the string, it will add the reference only, not gonna create a new string. So it will just create the reference, and using the backtracking we will get our original string. So that's why it will be the original string 6 times. So that's why we need to create new string whenever this is a endpoint. So we got our permutation. That's it. Let's submit this, and let's talk about time and space complex. So actually I did a mistake here. uh, it is saying the line number 37, and we are not returning anything. So first let's add this, and now let's submit this. And I was talking about time and space complexity. Let's find out what's the time and space complexity for this code. First let's for it wait for it to submit. Then I will go back to the whiteboard, and yeah, it will submit it. So we have solved this question. The code is provided in the description box. So let's suppose we have a string length 3. For string length 3 we got 6 different permutation. So isn't it 6 factorial? Yes. For n string we got n factorial, but this is not enough. For our base case is considering s, and we are considering a path, a ending, and we are converting it to a string. So this conversion will take order of n, and permutation will take order of n factorial. So it will be this, and our space complexity in the worst case will be order of n if we does not include the permutation. But if we include the permutation, it will be order of n factorial also, isn't it? Yeah. So we have solved this question, and let's find out. And we have made the expected time complexity. The space complexity is order of n if you consider only and only your recursive function. But if you consider your answer also, it will be order of n factorial, which I think they are not considering it. So we can state with order of n. So it will work. The constraint is very less, and it will work. Thank you all for watching this video.